approximation. Now, what is approximation? Approximation is, just a moment, approximation is rounding off or approximating the given number. Sometimes it is required to work with the number easily, so we approximate the number. Just for an example, if you have to pay 105 rupees to somebody, we can say approximately we have to pay 100 rupees. Got it? So that way we approximate. Now, how much or up to what digit we have to approximate depends upon our need or our requirement. It can be approximated to a whole number, it can be approximated to the nearest 2 decimal places, or it can be approximated to nearest 1000, or maybe anyway. Whatever is our need, we can approximate. We can understand it better by an example. Say, I have taken one example. We have a number 54321, that is 54,321. If I am required to round off or approximate to nearest 10, nearest 10 means instead of 21 it will be 20. So this figure will be 54320 if we are approximating it to the nearest 10. If we want to approximate to nearest 100, nearest 100 will be 543 and then 2 zeros. This is 54,300 is the approximation up to nearest 100. If it is to be approximated up to nearest 1000, then we will get 54 and 000 or 54,000. I hope something is clear. Now it will be more clear when I take example of the decimals. Say we have a decimal figure 0.12345. If we want to approximate it to the nearest 3 decimal places, 3 decimal places means the 3 digits after decimal point. Okay. So when we approximate it to nearest 3 decimal places, it will be 1, 2 and 4. Why? Before answering why, let me tell you what is the general rule or general terms how we approximate. Okay. So say I have to approximate it to the 3 decimal places. Then we will consider the next decimal place, that is 4. If it is less than 5, we will ignore it. We will not consider it. But if it is more than 5, then we will add 1 to the last figure where or up to which we have to approximate. But here you will see that I have taken 1 in spite of the 4th digit being as 4, because the 5th digit is 5. The 5, because of this 5, this will become 5, and because of this 5, when we approximate up to 3 decimal places, it will become 4. So I have written 0.124. If we want to approximate it to nearest 2 decimal places, it will be 0.12. Okay, because this 3 is less than 5, so we will ignore. Even if this becomes 4th digit becomes 5, this will be converted only up to 4. So we will have to ignore anything after 2 decimal places. So my answer is 0.12. If I am required to approximate it to the nearest 1 decimal digit, it will be 0.1. with the same principle which I have told. Okay. Now there is another word that is called as significant figures. Now what is significant figure? Significant figures is the first non-zero number. Okay. You will be more clear when I take example. For example, I have a number 6, 7, 8, 9. We have to round it to one significant figure. One significant figure means the first non-zero number is 6. So after that, using the same principle, if it is more than 5, we'll add 1. If it is less than 5, we'll ignore. So here it is 7. So this will become 7. So rounding off to the first significant figure will make it 7,000. Similarly, if we have another number 6.789, we have to round it to the two significant figures. The first two first two non-zero numbers are 6 and 7. So we will have to round it off up to this, and after that there is a figure 8. That means it is 5 more than 5. So we will add 1 here. So this will give me 6.8. I hope I am clear. Now it will be more clear if we take another example. Say I take an example of 0.000, that is 3 zeros, 6, 7, 8, 9, and I am required to round it off to 3 significant figures. Now my 3 significant figure will start from 6, because this is the first non-zero number. So 6, 7, 8. We have to round it off up to this point. Means there is a 9 after this, which is more than 5. So we will add 1 here. So this figure, this given figure rounded up to 3 significant figure will give me 0.000, that is 3 zeros, 6, 7, and then 8 converted to 9. So my answer is 0.306, 7 and 9. Got it? Then another term comes here that is called as estimation. Sometimes we are required to estimate a value. For example, if you want to buy some grocery or eatables for your party, you can't buy exact. You will have to approximate it, or you will have to estimate how much we will buy. Say we have 100 people in the party, and we assume that everybody will eat everybody will eat 100 grams. So 100 into 100 grams will make how much? It will be 10 kgs. Okay? Am I clear? So this 10 kg is an estimate only, because we have estimated that every person in the party will consume only 100 grams. Somebody may consume 80 grams, somebody may consume 200 grams. So it is just an estimation. Okay? So we need sometimes to estimate the values also. And you can use it for checking your answer also, whether your answer is correct or not, for any equation which you are solving. Okay? So I'll give you 2 examples. One, let us estimate the value of 36 multiplied by 2.1 divided by 2.38 multiplied by 1.9. So here, first of all, for estimation purpose, what we do, we round off to the nearest 1 digit, all the figures. So 36 will become 40, 2.1 will be 2, 2.38 will be 2, 1.9 will be 2. And we solve this. 40 into 2 is 80, 2 into 2 is 4. That means my answer, my estimate is 20. Actually, when you calculate this answer will be 26.470. But okay, this estimation is fair enough. We are not very out of phase. Okay, so this is the way how we estimate, and this is the process how you can check your answers if you are correct or not. Suppose you get an answer here, say 40 or 60 or whatever it is, then you can say there is something wrong because it should be around 20 only. Okay, so that way we can check our answers of any calculation also. Second example which I am taking is estimate the value of under root or square root of 27. What will be the value? So for this we will have to check this 27 is where it lies between which two numbers. Say, let us take an example of 5 square. It is 25. The next digit is 6. 6 square is 36. So 27 is definitely between the squares of 5 and 6. So under root or square root of 27 should be between 5 and 6. Now we inspect. 5 square is 25 and we have 27. So it is very near to 5. So we can estimate the square root of 27 as 5. Okay, and here we are using a different symbol, that is a curved lines. Instead of two parallel lines we use a curved line. This symbol is used to show it is roughly or approximately equal to. This is not exactly equal to 5, but it is approximately or roughly equal to. Okay, then what we can learn next is something about upper and lower bounds. Now, what is upper and lower bound? It shows the maximum and the minimum actual value that a rounded value can have or a rounded number can be. Okay, let us understand it with an example. Say I have a rounded number 9. So actual value what will be? It will be, say if I take 8.5 and round it off to one digit or one number, that is, it will become 9. So value rounded value of 9 could start from 8.5. Okay, and what will be the maximum number? The maximum value of this rounded figure 9 could be 9.499999 or say 4.5 if we round it off to the first decimal place. Okay, so my value of rounded figure 9 could vary between 8.5 to 9.5. Okay, so my upper bound, that means what is the maximum value which this rounded figure 9 could have, is 9.5 and the lower bound is 8.5. That means it gives the range within which the number is rounded off to 9. So any figure between, the actual figure will be between 9.5 to 8.5, which can be rounded to 9. Okay, let me take another example. Say I have a rectangular garden. It has sides of 20 meters and 10 meters. What is the maximum length of the wire required? That is also, we can say it means that we have to find out what is the upper bound of this rectangle. So since these are the rounded figures 20 and 10, what maximum value 20 can have? The 20 can have a value between 20.5 to 19.5. That means 20.5 is the highest value, or upper bound for this 20 is 20.5. Similarly for 10 it is 10.5. So my actual value or actual size of my garden could be 20.5 and one side, and the other side will be 10.5. So we calculate the perimeter, it makes 62 meters. Got it? So we will have to buy maximum 62 meters of the wire to fence it. Okay, whereas if we take the nominal size only, it will be only 60 meters. That means in this given example we will have to buy 2 meters extra wire so that we are safe and we will not fall short of the wire for fencing it. A similar word is used as truncated number. Truncated means it is cut. Okay, and here we don't round off the numbers. Simply we ignore or we cut the number. You can say any digit after the required number is deleted without rounding off. I'll take an example. Say I have taken an example of 1.45678 and 9, and I ask you to truncate it to 2 decimal place. Second decimal place is, first decimal place is 4, second is 5. So we will just ignore the numbers after that. So my answer will be 1.45. If I say truncate it to 4 decimal places, 4 decimal places means 4, 5, 6 and 7. Okay. So we will simply write, if we are truncating it up to 4 decimal places, it is 1.4, 5, 6 and 7. Here actually if we are rounding off, then this 7 will become 8 because of this 8 as the 5th number. Okay. So here for truncated numbers we don't round off. So it is simply we ignore the number after the required truncation. Okay. So my answer is 1.4567. Got it? Now let us move to other upper and lower bounds. They can be also written as intervals. Okay. Interval means, again what I have said is range, but the way of writing is slightly different. Okay. So same example which I have taken previously, I have used the word rounded number. Let me say it is the weight 9 kg. Approximate or rounded weight is 9 kg. What interval actual weight of bag W will have? Okay. So we can write same figure, whatever we have done in the last example. Say it is lowest value is 8.5, then we have a sign of less than equal to, then the weight. This weight is the approximated weight, which is 9 kgs and which is less than 9.5. So writing in this fashion is called as writing as in interval form or writing as interval. Okay, this is what I was supposed to tell you, something about this approximation. Okay, now next we will take up something about fraction or maybe some other topic, but hopefully fraction. Okay.